Okay.
Or if this looks kind of what you're used to seeing, more or less. Everything look good to you?
Yeah.
All right. So here's the graph. It's the baskets made, baskets attempted. So I guess they, they took some players. They said, okay, someone here took like 16 shots and they made, maybe 5 of them. Someone took 4 shots and didn't make any, things like that. And there's kind of a line through this. See this arrow here? Kind of a line through the data. Do you see that?
Yeah.
All right. So the first question here is asking, describe a method. The coach drew a line that showed the trend of the data. The line is called a trend line or line of best fit. So that's some vocabulary you might want to have down. And then it says here to how can a coach write an equation of the line? So the answer to that question is you need y equals mx plus b. Okay. And one thing you should notice is that the graph does start down here at the origin, right? If you take 0 shots, how many can you make?
Are you asking me?
Yeah, I'm asking you.
If I take 0 shots, how many can I
Yeah,
make?
if you
0?
ask, yeah, 0, right? If you don't ask, you'll never know. All right. And so the B value here is 0.
Yeah.
Because of that. Now the slope you can get from just sort of doing a rise over a run scenario. And it's sometimes good to sort of pick a nice place there. See how that's kind of, that line is right kind of on the grid there. So you want your rise and you want your run here.
Yeah.
Okay. So how much up are you going? Well, these are going by 2, 4, 6. And your run, we're going over to what looks to be 18. Does that look right to you?
Yeah.
Okay. What is 6 divided by 18?
2 or no 4 or 3. Sorry.
One third, right?
Yeah.
1/3. So the slope here is 1 divided by 3. All right. So now that's the equation of the line that they want. They want you to write mx plus b. In this case, you've got everything.
Yeah.
So the line would be y equals 1/3 x plus 0, or just 1/3 x.
1/3 x.
Yeah. Okay. Maybe we've done a bunch of this. Okay, so I guess A just wanted you to sort of describe it.
Yeah.
And then B is actually kind of carrying some of these things out. What are the 2 points for the line of best fit? So we used the origin 0, 0. That was this one in the lower left. The other ordered pair was this one here where there was 18 shots attempted and 6 made.
Yeah.
Okay, and that's what they're looking for there. What are the 2 points for that?
Okay. 0 and 0 and 18 and 6.
Exactly. Yeah. All right. So now this next question. This is actually a very interesting one for me, because it's asking you, does the line of fit have to include any points from the collected data? Like, do you actually have to use any of the data points to make the line?
Yeah.
The answer is kind of, it depends. You could go back to the graph here and you could get any 2 of these points. Okay, but if you chose the wrong 2 points, let me try to show you that here. So let me grab this. All right, so let's say we used, I'm going to grab red again here. Let's say we use these 2 points in red and we made a line like this. Would that be good? Does that describe the data?
Yeah.
It does. Looks like it's going like somehow a person could shoot 2 baskets but make 10 of them.
Then no.
So this does not follow the trend of the data. The data is going up and to the right, and that's what I meant by, well, you could choose 2 data points, but if you choose 2 that are wrong, it also wouldn't be very useful. Let's say you chose like this point and this point over here on the right, and the line Do you see how this kind of overshoots the,
Yeah, I do see that.
right? So this is where you see where people they'll take 2 data points. Are you an NBA guy? Do you like the NBA?
I used to play basketball until like 2 years ago, but yeah, I know a lot, I
You're not
guess, or good
so,
amount.
so ESPN sometimes puts up on their website kind of the score, the graphics of the scoring where the teams get further apart, then they come back together. Sometimes you can think, oh yeah, the team's going to win, and then the other team comes back. You got to be really careful with your samples here. You got to make sure that these actually are the best 2 data points. So the answer here to C is really like an it depends. Does a line of fit have to include any points from the collected data? It does not, but it could.
Yeah,
And I don't know, that's a very like almost like a political answer where you're not really answering it, but
yeah,
that is in fact what they're looking for. So we've actually done D&E, and we've actually already found the slope of the line of best fit. If you recall, it was 1/3.
okay,
And then we got the equation already. So we actually did everything that was needed for this.
okay,
Okay, the coach. Now we're on to F. Now we're on to F. Okay, so you're gonna definitely need your paper here to answer F. I'm gonna snip
okay,
in the graph.
got it. Do you, wait, are you saying like the paper of like,
Yeah, you're
like
gonna
notebook?
no this worksheet paper.
Yeah, I got it.
Okay,
Okay.
so let me draw a couple of lines here. See if I can do this well. All right, so here's a line. Let me draw another, or and this. So the idea is that this line here, it needs to go through. It needs to go halfway through the data points. I don't know why I can't resize this, but so actually I don't like that. Let me do it differently here. So here's a line. Here's a line, and here's a line, right? There's lots of lines you could draw, but you want to find a line that goes to the data points such that about half are above and half are below.
Yeah,
And you kind of got to eyeball here. Like there's 1, 2, 3, 4, 5. Below maybe 6, and then up here it's 1, 2, 3, 4, 5, 6, 7, 8. So maybe it needs to go up just a tiny bit. It's kind of hard to tell exactly, but you want to draw something that kind of goes through, so that the same are above and below. This one's now probably got too many below. So it's like, where is it? Where is that sweet spot where it's same number above and below? I don't know. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. So that one looks pretty good to me.
yeah,
And so that's what they're looking for. Now, you can't go past the origin, and then you're supposed to show an arrow out to the right. So you don't want to include this here, but that's what they're looking for. There's some sort of a rough estimate here.
okay,
Okay, so this is good. I mean, things that would be wrong would be, really things that are just way off. Like you could actually make the case that that line half are below and half are above, but it doesn't follow the data.
okay,
Okay, you could also maybe make the case that there's a line here that you can get half above, half below. But the problem is it doesn't follow the trend of the data. The data is going up and to the right.
okay.
Is that okay?
Yeah, yeah.
All right. So the
This is really like, I don't know. It's a lot
basic.
different.
Oh,
than-
yeah, it is. I mean, this is real life. This is data.
Yeah.
You go collect data, you plot it, and you look at it.
Yeah.
All right. So the instructions here, I mean, this feels really similar to what we already did. Draw a line of best fit and name 2 points on the line. So this time, I really like this point down here, the 0, 0. And you can see it actually kind of goes through that point up there, 20, 8.
And it goes to 20 and 8.
20 comma 8. You can see that I'm just reading that ordered pair right there where the cursor is.
Okay.
That's all it is asking for here in part F.
Okay.
All right, part G is the slope. Okay, so the slope here is the rise over the run. You can also use the slope formula here. Slope is y2 minus y1 over x2 minus x1. And so your
Okay.
first, you've got the ordered pair here, the ordered pair here. We'll use that to calculate the slope for us, please.
Wait, I'm kind of confused. Can you explain again? I'm sorry.
So we've got two ordered pairs, 0, 0,
Yeah.
and
Correct.
20, 8.
Yeah.
This is x1, this is y1, this is x2, and this is y2.
Okay, so would you put in? Okay, I got this now. So it'll be 8 minus 0 and 20 minus 0.
Good.
Okay. So it'd be 8 over 20.
Okay, does that reduce?
Yeah, it's a 4. Or no, yeah,
4 over
4.
10 is fine, but you keep going.
And then that would reduce to 1. Would that reduce to 1/2?
4 over 10,
2
like
over
what number
4.
goes into 4? What number goes into 10? Same number.
2 over 5.
2 over 5, good. All right. All right, and then the letter H here, kind of the final part here is to write the equation. So we've been doing this for a long time now. The equation of the line is y equals mx plus b. That number you just found, that 2/5 is the slope. 2/5 x plus b. Do you remember what the b value represents in the graph? Like what would you call it in the graph?
Would you call it like baskets made or?
Nope. The b value is always the y-intercept. Where does it
Oh,
cross the
0
y?
and 0.
Yeah, so it crosses at 0, so the b is 0 in this case.
Okay.
And that is it for this one.
Yeah.
Is there a backside to this paper that you need to send?
No, there's not. They're just all individual different ones.
Okay.
For the equation of the line or the U structure, what is the equation of line of fit? Would I put, yeah, y equals 2 over 5x.
Yes.
And then what about for the other one too? Would I put,
Which one?
because there's 2 of the U structures, what is what is the equation?
Okay, well, we've done G. G is the slope of the line. That's 2/5.
Yeah.
Okay, you did all that. And then H is the equation, which is down here.
Okay, got it. Okay, we can move on now.
Okay. All right, so the last question, the reason I ask is because it's really odd that it would have just part A in example 3 without B. Like there should be a part B
Yeah.
to this, but I don't see it. So what sometimes these things do is they create a scenario and they're hoping students will like appreciate the importance of this. So this one says the hours the students spend studying is compared to the hours they spend watching television. Okay.
Okay.
And they're saying like the more time you spend watching TV, the less time you spend studying. Okay.
Okay.
And like the, in today's terms, it's like number of hours spent on your phone, number of hours spent studying. Right. So they're trying to get you to see like, oh, if you spend a lot of time on your phone, you don't have very much time to study.
Yeah.
And if you spend all your time studying, you don't spend much time on your phone.
Okay.
So they're hoping you'll see that and be like, oh, you know, I should spend less time on my phone or stop watching TV.
Yeah.
Okay, they give you an equation, which is nice. And it says, the question here is the correlation positive or negative? Okay, and I'm going to give you the two graphs. So positive correlation goes up and to the right.
Okay.
Now, in words, what this means is that the more of the one thing you do, the more of the other that you do.
Okay.
So let's, I don't know, the more shots you take, the more points you score.
Okay.
Something like that. Okay. Negative correlation is when it goes in the other direction. It goes, and I should say up and to the right. Negative correlation is down and to the right. So negative correlation occurs when you like the more of one thing you do, the less of another that you do.
Okay.
Yeah, the hotter it gets, the less time you spend outside, maybe.
Yeah.
Something like that. But they're it's called an inverse relationship, and the other one's called a direct relationship. You have to know both of these plots. You have to know both of them so well that when you see a graph like this, you immediately know which one it is. Is this one a positive or negative correlation?
What, the top one?
Yeah.
Would it be negative?
Yes. Now, when it says, how do you know, or what is your reasoning, you want to say that as, for example, hours studying increases. Okay, that means you have less time, less hours watching TV.
Okay.
And you might have seen this kind of notation in class where it's like, as one thing goes up, the other goes down, or as one thing goes down, the other goes up. These are both inverse or negative relationships.
Okay.
The other way you can remember it, if you don't like any of that, if you're like, man, I'm not sure I remember all that, is look at the slope of this line. Is the slope of this line positive or negative?
Negative.
Negative, and that's the correlation. Slope of the one going up and to the right is positive, so it's positive correlation. That might be an easier way to remember or think of this.
Yeah.
All right, any questions on that?
No, not really.
Okay, so I'm going to find a couple of quick positive and negative correlation things for us to look at. Unless you got something else for us to look at today.
No, I don't really, to be honest.
Okay. All right. Let's take a look at this here. All right, you're able to see this okay? It's not too small.
Yeah, it's good.
All right, so the scatter plot below shows the average traffic volume and average vehicle speed on a certain freeway for 50 days in 1999. So wow, that's pretty old. So what they're showing you here is that as you go faster, so like a point up here, the volume is less. And as you go slower, the volume is increased.
Yeah.
And then when they talk about volume, they're talking about congestion. So does that intuitively make sense to you that at slower speeds, you're going to have more congestion than say at higher speeds?
Yeah, it does make sense.
Okay. And that's what it's talking about here. Okay, it's like are these things positive or negatively correlated?
Okay.
Right. So here's another graph for you to look at. All right. So the temperature of heated water, and they're showing you that the water temperature here. So the water temperature rises as the heating time goes to the right. So does
Okay.
that look consistent with what you understand, that if you take longer to heat something, it should get hotter?
Yeah.
If you put a pot of water on the stove and then you wait a minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, it should eventually get a lot hotter. All right. So the truth though is that not everything is correlated.
Oh, yeah. Okay.
And here's an example of this. This will be our last sort of thought. There is such a thing as no correlation. And that's when it's neither increasing or decreasing. So the question is there a trend line here? Is there like something you could say, like, as absences increase, is that related to class size, or are they totally unrelated?
It'll be related to class size.
So maybe you intuitively think that, but according to the data here, we don't actually know whether the line goes down or the line goes up.
Yeah. Okay.
We can't tell that, and not everything is correlated. Most things are correlated, but they don't have causation. Like, one does not actually affect the other. All right, so we're going to go ahead and stop here for today.
Okay.
All right, so